Detailed explanation. How earthquakes happen. Earthquakes are powerful natural events that occur when energy stored in the Earth's crust is suddenly released. This release of energy creates seismic waves, which travel through the Earth and cause the ground to shake. Although they can vary in intensity and duration, all earthquakes share similar causes rooted in the structure and dynamics of our planet. 1. Earth structure and plate tectonics. To understand earthquakes, we first need to understand the Earth's structure. The Earth is made up of several layers. Crust, the thin outermost layer where we live. Mantle, a thick semi-solid layer beneath the crust. Outer core, a liquid layer composed of iron and nickel. Inner core, a solid sphere at the center of the Earth. The crust and the upper part of the mantle form a rigid layer called the lithosphere, which is broken into large pieces known as tectonic plates. These plates float on the softer layer of the mantle beneath, called the asthenosphere. Because of heat from the Earth's core, convection currents form in the mantle. These currents cause tectonic plates to move, though slowly, at just a few centimeters per year. 2. Types of plate movements. There are three main types of boundaries where plates interact. Convergent boundaries, plates move toward each other. One plate may be forced beneath another in a process called subduction, often creating earthquakes and volcanic activity. Divergent boundaries, plates move apart, creating new crust. These are common under oceans and can cause mid-ocean ridges and small earthquakes. Transform boundaries. Plates slide past one another. This side-by-side movement creates intense friction and can result in powerful earthquakes, especially along fault lines. One of the most famous transform boundaries is the San Andreas Fault in California, where the Pacific Plate and North American Plate grind past each other. 3. Faults and stress accumulation. A fault is a fracture or break in the Earth's crust where two blocks of rock move past one another. Faults can be very small or hundreds of kilometers long. As tectonic plates move, they don't always slide smoothly. Instead, they get stuck because of friction. Over time, stress builds up along the fault. When the force of the stress overcomes the friction holding the rocks in place, the rocks suddenly slip. This sudden slip releases energy in the form of seismic waves. 4. Seismic waves and ground shaking. There are three main types of seismic waves. P waves, primary waves. These are the fastest seismic waves and move through solids, liquids, and gases. They compress and expand the material they pass through like a sound wave. S waves, secondary waves. These travel slower and only move through solids. They move the ground up and down or side to side. Surface waves. These travel along the Earth's surface and cause the most damage. They move in a rolling motion and are slower than P and S waves. The focus, or hypocenter, is the point underground where the earthquake starts. The epicenter is the point on the surface directly above the focus. 5. Measuring earthquakes. The strength or size of an earthquake is called its magnitude. It is most commonly measured using the Richter scale or the moment magnitude scale, MW. These scales measure the energy released during an earthquake. A magnitude 2. 0 earthquake is very minor and may not be felt. A magnitude 5.0 earthquake can cause noticeable shaking and minor damage. A magnitude 7.0 plus earthquake can be devastating. Seismographs are instruments that detect and record seismic waves. By comparing data from multiple stations, scientists can locate the epicenter and calculate the earthquake's depth and magnitude. 6. Effects of earthquakes. Earthquakes can cause various kinds of destruction. Ground shaking damages buildings, roads, and bridges. Surface rupture. The ground can crack or shift. Landslides, especially in hilly or mountainous areas. Tsunamis. Underwater earthquakes can displace water and generate massive sea waves. Aftershocks, smaller quakes that follow the main event, which can continue for days or weeks. 7. Human impact and preparedness. Millions of people live in seismically active areas. Engineering solutions such as earthquake-resistant buildings, emergency preparedness plans, and early warning systems help reduce the impact. Some examples. Japan uses advanced sensors and trains that automatically stop when seismic waves are detected. California has strict building codes and public drills. Nepal, which lies on a major fault line, has focused on rebuilding stronger after past quakes. Can earthquakes be predicted? Currently, earthquakes cannot be predicted with exact timing. Scientists can forecast the likelihood of earthquakes in a region based on past data, fault maps, and stress levels, but they cannot say exactly when on.